Voice is audible. Okay, so see, into the today's lecture, we will going to cover a very important point. That is nothing but the output equation of the transformer. Okay, so what we have to do, depending upon that, means whatever the output equation of transformer is there, on depend by taking the reference of that, we have to solve the example. So first of all, we have to study the output equation of single phase core type transformer and shell type transformer, and then we have to go for the output equation of three phase core type transformer and shell type transformer. See, three phase shell type transformer, it is somewhat different, but the what I can say, single phase core type transformer, single phase shell type transformer, and the three phase core type transformer, both are having somewhat equal linking. So just first of all, we will discuss thoroughly related to the what I can say for the single phase core type transformer. What about the single phase shell type transformer, that I will tell after the completion of single phase core type transformer. And what about the what can I say, single phase three phase core type transformer, that I will also tell. Okay, so first of all, we will study the what I can say output equation of single phase core type transformer. Single phase core type transformer. Okay, now see, for this, how we are going to, for this, see, there is one figure which we have to take the reference for drawing this particular or for deriving the equation, that is nothing but the single phase core type transformer. How that figure is, simple two-dimensional figure of transformer is there, but just what they have indicated, that is important. I will not draw that much big, because we require this lot of full space for deriving the equation. Okay, so I will just draw somewhat a small figure here. Okay, now see what we have shown here, that is a very important. What we have shown, a suffix small w, whatever this a suffix small w is there, this is called as the window area. Okay, this is called as nothing but the window area, and whatever this window area is there, that is applicable for deriving the equation of single phase core type transformer, that is shown here by this particular line. या लाइन नी तो काय केलेला आहे आपण, एरिया दाखवलेला आहे. ओके, now see here, now this is nothing but the one of the distance, that is nothing but the capital D. What that capital D stands for? Capital D stands for the distance between core centers. Okay, म्हणजे काय बघा, आता तुम्ही जर हा पर्टिक्युलर हे कोर कन्सिडर केलं, व्हॉट एव्हर दिस आउटसाइड, इफ यू आर कन्सिडरिंग इट एज द कोर, so what it will happen, here is one center and here is also one center, and whatever this D is there, that is distance between this point to this particular point, that is nothing but the capital D. Okay, don't confuse between capital D and small d. Small d is also going to appear here, but whatever this capital D is there, that is considered as the distance between core centers. Why? this point and consider this point. This it is at the center. हे distance इथून ते इथपर्यंत घेतलेलं नाही. ओके, फ्रॉम दिस पॉइंट टू दिस पॉइंट इट इज नॉट कन्सिडर्ड. कुठून कुठपर्यंत कन्सिडर केले? फ्रॉम दिस सेंटर to this particular center. That's why it is nothing but the distance between the core center. And again, very important point is there here. Okay, आता ऍक्च्युअली काय बघा, इथे जे मी तुम्हाला डॉटेड दाखवतोय, दिस वन. ओके, दिस डिस्टन्स इज नथिंग बट दी स्मॉल डी. ऍक्च्युअली दिसतंय का सगळ्यांना? बघा, दिस डिस्टन्स इज नथिंग बट दी स्मॉल डी. नाउ व्हॉट इज दिस स्मॉल डी? That small d stands for the diameter of a circumscribing circle. So what is the meaning of circumscribing circle? See, although what I can say, our core, actually our core is from here to this particular point, but what we have did, we have considered somewhat extra part. बघा, मी डॉटेड लाईन पूर्ण त्या ह्याच्यावर दाखवलेली नाहीये. कशावर? त्या लाईनवर दाखवलेली नाहीये, त्याच्यात थोडंसं पुढे दाखवलंय. Why? Circumscribing circle means what? Whatever the effect of magnetic flux is there, that is applicable up to that point. Okay, म्हणजे जरी तुमचं मॅग्नेटिक फ्लक्स या कोरला जरी लिंक होत असलं, ह्या पर्टिक्युलर पॉइंट पर्यंत ही त्याची जरी बाउंड्री असली, तरी इथपर्यंत न होता ते कुठपर्यंत लिंक होते? एक जस्ट मिलीमीटर स्मॉल काय म्हणतो तेवढा पोर्शन आहे तो, की आपण इथे दाखवलेला आहे. ओके, इथं आणि इथे दाखवलेला आहे. दॅट इज नथिंग बट दी व्हॉट? Distance of, or we can say that diameter of the circumscribing circle. Circumscribing circle means what? The circle, or we can say diameter, where the effect of magnetic flux is going to be observed there. तिथं magnetic flux चा इफेक्ट काय होतोय? ऑब्झर्व होतोय. म्हणून तर ह्या पर्टिक्युलर लाईन वर न घेता ह्या पॉइंट पर्यंत दाखवलेलं आहे. ओके, हे आपल्याला ह्याच्यात लागणार नाही, पण ज्यावेळेस आपण आता मेन डायमेन्शन्स फाइंड आउट करू, whenever we will going to find out the main dimension, that time we will require this. Okay, yes. Now see, whenever we are going to derive this particular equation, there are some assumptions in the sense notations were there. Okay, जे की तुम्हाला ज्यावेळेस एक्झाम मध्ये क्वेश्चन विचारला जाईल, आयएससी मध्ये derive the output equation of single phase core type transformer, that time you have to mention that notation or that assumptions there, and then only you have to start for the deriving that proof. Okay, so first of all I am going to write here this particular dimensions were there. See, first and foremost important, that is nothing but the yes. What is that? Yes is nothing but the, see, I am writing here the output of transformer in kVA. What that S stands for? Output of transformer in kVA. Then this A suffix small w, काय सांगितलं मी? A suffix small w, that is nothing but the window area. How we are going to measure this area? In the meter square. Okay, area आपण कशात मेजर करतोय? Into the meter square. Then A suffix small c. What that A suffix small c stands for? That is nothing but the copper area. Okay, means what? As you are knowing that whatever the our turns are there, or whatever the what I can say core part is there, in that copper is there present. So whatever that area of copper is there, that is which is denoted by the letter, what I can say, A suffix small d, that is nothing but the copper area, which we are going to measure it into the meter square. Then there is another important terms, that is nothing but the K suffix small w. What that term? That term is considered as the window space factor. What that term is nothing but the window space factor. आता विंडो स्पेस फॅक्टर काय ते आपल्याला प्रूफ मध्ये बघायचं आहे. आपल्याला प्रूफ तिथूनच स्टार्ट करायचं आहे, फ्रॉम दी विंडो स्पेस फॅक्टर. ओके, देन नेक्स्ट इज नथिंग बट दी व्हॉट आय कॅन से I1, I2. Which are that? What you can say I1, I2? काय शकतील? Primary and secondary winding current. Okay, that is nothing but the primary and secondary current, which is obviously in which particular parameter we are going to measure it. Current kashat, obviously it is measured it into the ampere. Next, see T1 and T2. What that T1 and T2 stand for? See, आतापर्यंत आपल्याला काय माहित होतं, for the number of turns we are using N. Okay, but as far as machine design is concerned, we are using that notation as a T. Okay, so what that T1 T2 stands for? Number of primary and secondary turns. So what is that? Number of primary and secondary turns. Okay, I1, I2, T1 and T2. Then next is nothing but the A1, A2. A1, A2 stands for the area of the cross section for the primary side, and A2 stands for the area of cross section for the secondary side. Okay, so what that A1, A2, area of cross section. Area of cross section. In which particular parameter we are going to measure it? Area. It is obviously we are going to measure it into the meter square. Okay. Next, D तर तुम्हाला obviously माहिती आहे what that capital D stands for? Distance between core center. What is that? Distance between the core center, which is obviously measured into the meter. Then small d, what that small d stands for? Diameter of circumscribing circle. Diameter of circumscribing circle, which is obviously measured it into the meter. Okay, then phi suffix small m, what that stands for? Phi m, maximum flux. Okay, what that stands for? Maximum flux. Obviously flux which we are going to measure it into the flux kashat measure karto? Weber. We are going to measure it into the Weber. Then B suffix small m, what that stands for? Maximum flux density. What that? Maximum flux density. That we are flux density आपण कशात measure करतोय? In which parameter we are measuring? Correct. That is nothing but the Weber per meter square. Okay. Then next, another one, that is A suffix small I. Okay. See what we have mentioned here, A suffix small c, that is nothing but the copper area. Then A suffix small I stands for the iron area which is present there as far as the transformer is concerned. Okay, that is nothing but the iron area which is obviously measured it into the meter square. Okay, म्हणजे तुम्हाला काय करायचे, whenever you are going to deriving the proof, at that time what you have to do, you have to mention all assumption there, and then only you are going to start that proof. Without mentioning this particular, what can I say, assumption, or without mentioning this particular notation, it is not accepted to start the proof. का? कारण कशाला काय म्हणले हे आपल्याला माहित नाहीये. Although we have studied, but whenever we are going to derive the proof, that time you have to go with the proper manner. Okay, there is also important terms, that is nothing but the E suffix small t. ते आपल्याला इथे यूज करायचे नाही, तरी पण असू द्या लक्षात. E suffix small t stands for EMF per turn. It is not only EMF. What that stand for? EMF per turn. आता EMF per turn काय ज्यावेळेस येणार आहे तो त्यावेळेस मी सांगतो. What is that? EMF per turn. Okay. So these are the different assumptions were there. सगळ्यांना समजलेत का? आणि हे assumption लिहिताना व्यवस्थितच लिहायचे आहेत. यात कुठलाही शॉर्टकट यूज करायचा नाही. ओके, किंवा आता तुम्हाला तिथे काय म्हटलं आपण phi m, फक्त फ्लक्स आणि ब्रॅकेट मध्ये वेबर, इट इज नॉट एक्सेप्टेड. मॅक्झिमम व्हॅल्यू ऑफ फ्लक्स, DM stands for maximum flux density, which is measured it into the Weber per meter square. कळलं का सगळ्यांना? Whether everyone got this? Okay. So these are nothing but the what you can say assumptions were there that is required for deriving the proof. Okay. So we will start with the now actually for deriving the proof. हाँ सगळ्यांना हे assumptions कळलेत का? Should just I erase it? Don't draw here photo. It is already available in whatever the YouTube video which I am recording. Okay, you can study that. We will write proof here. Don't worry about the proof also. But if you are writing this assumption, we will require what I can say 2 hours for completing that only one proof. If you are writing here only, what you will do? You just go to there. What can I say? Whatever the video lecture we are having on our teaching diary, and from that teaching diary you can write down it in our notebook so that it will be practicable for you also. Whatever the example will there, whenever I will solve here, I will give you time for writing the example. Okay. Okay, so see, first of all, we will start with the proof, what you can say, window space factor. So what is that window space factor, which is denoted by the letter KW? So what is that window space factor? It's still 10-15. If you are doing like this, then what it will happen? अजून आपल्याला 4:30 पर्यंत जायचंय. काळजी घ्या, नाहीतर ज्याला कुणाला त्या फॅनची अलर्जी असेल त्यांनी त्यांच्या पुरता तिथला फॅन बंद करा फक्त. So what is that window space factor? See, window space factor, it is the ratio. It is the ratio of total copper area to the total window area. आता actually आपल्याला window space factor ची value, whenever we are going to solving the example, into the example the value of window space factor is given to us directly. They are directly mentioning that consider window space factor as, and they are mentioning that value. So what is that? It is the ratio. कशाचा ratio आहे? It is the ratio of copper area to the total window area. So how we are going to denote the copper area, which is nothing but the AC, and how we are going to denote this particular window area, that is nothing but the AW. And see, this letter, काय काय जणांना काय सवय असते माहितीये का? Whenever I am checking paper, observing that they are writing A and this capital C. This is not our notation. What we are writing? A suffix small c. Suffix मध्ये लिहायचं आहे. This AC stands for the alternating current. आले का लक्षात सगळ्यांना? This AC stands for the alternating current. See, in our every, you can consider every subject or whatever it may be, the notation is having its own meaning, as well as whatever the, what we can say, its unit. These very important. Okay. Now see, if I have to find out the value of AC from this equation, what will be that value? That is nothing but the AC is equal to AW into KW. So this is nothing but the my equation number first that I am requiring for deriving the proof. Okay. See, now whatever the equation number we are giving, these equation also we will require whenever we are solving the example. Have you got it? means it is not like this. This equation number 1 is not required for us. If the copper area is given to you and window space factor is given to you, how you can find out the window area? By using this equation number 1. आले का लक्षात सगळ्यांना? So whatever the equation that which we are deriving it into the proof, that is also required whenever we are going to derive the output equation. Considered? Okay. Now there is another method for finding out the copper area. Okay. पहिला आपण कुठल्या मेथडने फाइंड आउट केलाय? We have found out the first copper area by using the or with the definition of the window space factor. Now there is another method for finding out this particular, what I can say, copper area. That is nothing but the copper area of the primary winding plus copper area related to the secondary winding. Yeah, I got it. I will write here. Yes. Now is it visible? Is it no? Yes, I will write from here. Okay. So what is that? How we can find copper area of primary winding plus copper area of secondary winding. Okay. Now see how we can find out the area. See, आपल्याकडे number of turns किती आहेत? How many number of turns were there for the primary? How much it is? T1. And what is my area? That is nothing but the, for primary it is A1. And as far as secondary is concerned, number of turns are and what is the area? That is nothing but the A2. So how I am writing this equation? See, T1 into A1 plus T2 into A2. Now what that T1 stands for? T1 stands for the number of primary turns. A1 stands for the number of area of cross section of primary side. Then T2 number of secondary turns and A2 area of cross section for secondary side. But you know that one equation. What is that equation? How we are going to write the equation for the current density? See, if I am going to consider the current density as this particular delta. Okay. So what is the formula for current density? Current divided by area. Okay. Current divided by area. So what we are assuming is that whatever this current density is there, that is same throughout this particular, what can I say, core. So if I have to write it like this, see, for current density for primary side, what is that? Current, that is nothing but the I1 divided by, what is the primary area? That is nothing but the A1. Okay. Then if I have to write for secondary, what will be that? That is nothing but the current I2 divided by, it is nothing but the A2. So same I mean here from this equation, if I have to find out the value of A1, what will be that? That is nothing but the I1 divided by delta. And if I have to find out the value of A2, that is nothing but the I2 divided by delta. So put that value here. I am putting T1, that is nothing but the A1. I1 divided by delta, then T2 is equal to I2 divided by delta. So what can I take common from here? That is nothing but the delta. That is 1 upon delta into the bracket T1 I1 plus T2 and I2. Now what we are assuming? We are assuming that, see, what is our assumption? I am going to tell you that T1 I1 that is equal to T2 I2 that is equal to TI. म्हणजे जनरली आपण assumptions केले. ओके, काय assumption केले? त्याला फक्त T into I कन्सिडर केले. म्हणजे काय? T1 I1 T2 I2 हे आपल्याला माहित आहे. That is for primary and that is for secondary. For in order to go for the derive the proof, we are generally assumed it as nothing but the T into I. लक्षात घ्या, T into I जरी अज्युम केलं असलं तरी ती दुसरी क्वांटिटी नाही. T म्हणजेच काय? नंबर ऑफ टर्न्स and I म्हणजेच काय? करंट. Okay, so what I will put the value here, so what it becomes 1 upon delta Ti plus this is nothing but the Ti, correct? This Ti becomes the what? Ti into Ti, what it becomes? 2Ti, absolutely. What it becomes? I am going to write here only, in front of here. What that it becomes? It is equal to twice Ti divided by delta. बरोबर है का? What is here at the right hand side? That is nothing but the AC. Twice Ti divided by delta. Now I am giving it as the equation number second. Now see, into the equation number second and into the equation number first, what is common? Left hand side is common, that is nothing but the copper area. So can we equate the right hand side? Okay, so how I am writing, see carefully, that is nothing but the AW KW is equal to twice Ti divided by delta. So from this equation I have to find out this value of T into I. So what will be that value? T into I, that is equal to AW KW delta divided by 2. That is my value. Okay, that is I am giving it as equation number 3. So what is my equation number 1? We have found out the copper area with the definition of window space factor. It is the ratio of copper area to the total window area, which is AC divided by AW. Then by taking the reference of primary and secondary winding, we have found out the value of AC. That is equation number 2. And now by taking the reference of equation number 1 and equation number 2, we have found out the equation number 3. Now see, this is the basic things that is required whenever we are going to derive the equation. Now, what we are going to derive the equation for S. S is nothing but the output of that particular transformer, it into the kVA, kilovolt ampere. So as far as the electrical machine design is concerned, the output of transformer is given by EI into 10 raised to minus 3 kVA. That E stands for the EMF. It is not related to the EMF per turn. EMF is different and EMF per turn is different. That I stands for the current. Okay. Now, what is the EMF equation of transformer? Correct. That is of what? See, 4.44 F phi m into N. But here, instead of N, what we are using? T. So what I am putting there? T into I into 10 to the power minus 3. Okay. Now, what that Ti? We have found out this value of Ti. It into this particular equation number 3. So put this value here. So what it becomes? 4.44 F phi m into what is the value of Ti? AW KW del divided by 2 into 10 to the power minus 3. So what I am going to do? I am going to divide it. See here, it becomes 2.22. So what I am writing here, see, 2.22 F phi m AW KW del into 10 to the power minus 3. Okay. Now see, we are knowing this particular equation. This phi m stands for the maximum flux. Okay. This phi m stands for the maximum flux. Now, what is the formula for flux density? What is the formula? That is nothing but the Bm. Bm is equal to phi m. म्हणजे काय? Flux divided by area. But here whenever we are going to consider this particular machine design, here we are going to consider whatever the assumptions that we have first of all taken, that is nothing but the AI, that is nothing but the iron area. So what is that? Phi m is equal, bm is equal to phi m into AI. So what is the value of phi m here? What I can find out? Phi m is equal to bm into AI. So if I will put this value here, what it becomes? 2.22 F. Phi m is equal to bm into AI, AW, KW, del into 10 to the power minus 3. So whatever this we are getting, that is nothing but the S is equal to 2.22 F BM AI AW KW del into 10 to the power minus 3. This is nothing but the output equation of the single phase core type transformer. So what that F stands for? F stands for frequency. BM stands for maximum flux density. AI stands for the iron area. Then AW, window area. KW, window space factor. What that delta stands for? Current density. And this 10 raised to minus 3 as a constant. What is my unit here? It is measured in kVA. ज्या वेळेस तुम्ही फायनल डिराइव करता इक्वेशन, that is S is equal to 2.22 F BM AI AW KW del into 10 raised to minus 3 kVA. ओके, हे kVA लिहायला अजिबात विसरायचं नाही. whenever you are writing at this end, don't forget to mention there kVA. Why? Because we are measuring that output in kVA. लक्षात घ्या, ज्या वेळेस तुम्हाला इक्वेशन मध्ये किंवा एखाद्या ह्याच्यामध्ये एक्झाम्पल मध्ये इफ दे हॅव गिवन द आउटपुट ऑफ ट्रान्सफॉर्मर इट इनटू MVA, डोंट टेक इट ऍज इट इज MVA, कन्वर्ट दॅट MVA इनटू KVA. जर तुम्ही MVA घेऊन एक्झाम्पल सोडवलं तरी तुमचं एक्झाम्पल गॅरंटेड चुकणार आहे. का? कारण वी आर डिझायनिंग फॉर दिस पर्टिक्युलर KVA. म्हणजे जर तुमची व्हॅल्यू 0.2 यायची असेल मीटर, कशाची, जे काय हाईट आहे विंडोची, ती काय येणार आहे? 0.002 अशी येणार आहे. कारण तुम्ही त्या MVA ला KVA मध्ये कन्वर्ट केलेलं नसणार आहे. त्यामुळं ज्यावेळेस एक्झाम्पल तुम्हाला गिवन आहे, whenever example is given to you, that time what care you need to take is that what care you need to take, convert that MVA into KVA. If it is given in MVA, जर KVA मध्येच दिला असेल तर कन्वर्ट करायची गरज नाही. there is no need for the conversion. Got it everyone? Now see, what we are doing is that this is the output equation of the single phase core type transformer. Now if they will ask that output equation of single phase shell type transformer, the output equation of single phase core type as well as single phase shell type transformer is same. There is no difference into the output equation of single phase core type transformer as well as single phase shell type transformer. बऱ्याचशा वेळा मी असं ऑब्झर्व केलेलं आहे, whenever we are what happens, आपल्याला प्रॅक्टिस काय, आउटपुट इक्वेशन ऑफ सिंगल फेज कोर टाइप ट्रान्सफॉर्मर, आणि त्याच्या खाली नोट काय लिहायची, द आउटपुट इक्वेशन ऑफ सिंगल फेज कोर टाइप एज वेल एज शेल टाइप ट्रान्सफॉर्मर इज सेम. पण एखाद्या वेळेस एक्झाम मध्ये विचारलं द आउटपुट इक्वेशन ऑफ सिंगल फेज शेल टाइप ट्रान्सफॉर्मर, स्टुडंट्स आर सेइंग दॅट वी हॅव नॉट कवर्ड दॅट पार्ट. ओके, and don't write their note as that, what I can say, deriving the output core and mentioning their output equation of single phase core and shell type is same. तसं नाही करायचं. ज्यावेळेस विचारलं derive the output equation of single phase shell type, हेच इक्वेशन derive करायचं. जरी त्यांनी विचारलं आउटपुट इक्वेशन ऑफ सिंगल फेज कोर टाइप, वी हॅव टू डिराइव्ह दिस इक्वेशन. ही नोट कशासाठी लिहिणार आहे? फॉर युअर अंडरस्टँडिंग. ते तसं तुम्ही एक्झाम मध्ये लिहू नका की the output equation of single phase core type and shell type is same. That is for your understanding. Okay, म्हणजे डिराईव्ह करून मार्क तर ऑब्व्हियसली तुम्हाला मिळणारच आहे, कारण तुम्ही ती इक्वेशन डिराईव्ह केलंय, पण ते काय दिसते, तुम्ही ब्लँक मॅन्डेटली केलेलं दिसते. आलं का लक्षात? म्हणजे सरांनी आपल्याला हे शिकवलंय, ही एक नोट दिली होती खाली, ते नोट लिहिली आपण, मग ते झालं शेल टाईपचं इक्वेशन. तसं नाही, म्हणजे ते स्टडी केल्यासारखं वाटत नाही की हा हे एक्झाम मध्ये येणार आहे म्हणून पहिल्यांदा लिहिल्यासारखं वाटतं. ओके, सो व्हॉट यू हॅव टू कीप इन युअर माइंड, द आउटपुट इक्वेशन ऑफ द सिंगल फेज core type transformer and single phase shell type transformer is same. Got it everyone? Okay, so within a 5 minutes we will write down this equation. So first of all, draw this diagram. Draw this diagram fast, don't waste the time. Pat draw kara. Output equation of single phase core type transformer. हा काय काय जण वहीच्या मागण्या लिहायला लागलेत, काय भानगड आहे? Those who are attending online, whether they are getting this point. Hello?
Yes, sir.
You are getting this point? Yeah. Diagram draw केली का? Right hand side diagram draw करा. पेन सॉरी पेन्सिल वगैरे वापरण्याची गरज नाही. नो नीड टू यूज इट. पेनानेच ड्रॉ करा, मार्क तेवढेच मिळणार आहेत आपल्याला. केलंय? ओके, कीप सम स्पेस ब्लँक देअर. ओके, काही स्पेस तिथं ब्लँक ठेवा का, यू हॅव टू राईट देअर अझम्पशन्स. ओके, स्पेस ब्लँक ठेवा, त्याच्या खाली चालू करा, बिलो दॅट राईट डाऊन. हा, एक 10 to 15 line, keep it blank and write down behind it. Yeah. Window space factor is defined as it is the ratio of total copper area to the total window area. Total copper area to the total window area. Okay, write down up to the equation number 1. Write down there. ते पलीकडचं KW आहे बरं का, दिसत नसेल तर that is KW which is shown there. Upper side, left hand side. Equation number 1 पर्यंत लिहा सगळ्यांनी. ओके, लिहिलं? त्याच्या खाली लिहा. We can find out the copper area. We can find out the copper area by taking the reference of primary and secondary windings. Like okay, इक्वेशन नंबर 2 पर्यंतल्या सगळ्यांनी राईट डाऊन अप टू द इक्वेशन नंबर 2. इक्वेशन नंबर 2 पर्यंत. Where is equation number 2? Here is the equation number 2. See here. Here is equation number 2. You have to write up to this. But don't write blank mindedly, because what we did here, we have put it instead of A1, this value. And we are assuming it as T1 I1 that is equal to T2 I2 that is equal to T into I. ते इथं मेन्शन केलेलं नाही, पण प्रूफ करताना मी सांगितलं होतं, त्यामुळे ते तुम्ही तिथं लेफ्ट हँड साइडला राईट हँड साइडला कुठं तर लिहून घेतलं तरी चालेल. सांगितलं सेम थिंग आय टोल्ड यू. आपण ही व्हॅल्यू पुट केलेली आहे ती लिहून घ्या सगळ्यांनी. कुठं तर कशावरून ही व्हॅल्यू पुट केलेली आहे. Completed. Girls, completed. Boys, okay. Below that, write down from equation 1 and 2. From इथं याच्यानंतर लिहा, हे इक्वेशन 2 लिहून झाल्यानंतर त्याच्या खाली लिहा इथं from equation 1 and 2 and write down up to this equation number 3rd. Equation number 3rd. लिहिलं. इक्वेशन नंबर 3 लिहिलं सगळ्यांनी. Below that, write down the output of transformer is given by yeah, start from here. See, start from here up to this last point, write down. But make sure that instead of TI, what we have put here, and instead of phi what we have put it here, you should know. लिहिलं? Completed? Everyone? Okay. So below that, write down node, node, N-O-T-E, node. Yeah. The output equation of single phase core type transformer, single phase core type transformer, and single phase shell type transformer, single phase shell type transformer is same, is same. Completed? Okay. आता बघा, हे जर तुम्हाला प्रॉपर मेथड लक्षात आली असेल ना, only 2 different points are there into the 3 phase. Okay. Whenever tomorrow we will study, that I will tell you. Only this part is different, this second part, and this part is different. That is nothing but the yes. इथे फक्त 2 नंबर ऍड करायचे, then it becomes the 3 phase transformer proof. Okay. It becomes the 3 phase transformer proof. कळलं का सगळ्यांना? त्यामुळे याची आणि त्याची मेथड ऑफ दिस and method of that 3 phase core type, there is no difference in deriving that equation. Okay, same method is there, only just we have to make the changes according to the whatever the figure that which we are drawing tomorrow. Okay, सगळ्यांना कळलंय का? हे इक्वेशन माहित पाहिजे. लक्षात घ्या, इक्वेशन जर माहित नसेल तर आपल्याला एक्झाम्पल सॉल्व करता येणार नाही. We are unable to solve the example without this particular equation, because every time whenever we are solving this equation, we are requiring this, solving the problem, we are requiring this equation, because ultimately what is our aim? To find the output. And how we are going to find the output? By using this particular equation. Everyone got this point? Okay.